Have you ever just looked at a simple shape, like a rectangle, and just kind of accepted it? Well, today we're going to pull back the curtain on the shapes that are all around us. We're going to find the simple, beautiful logic that proves why they work the way they do. I mean, think about it for a second. We can all point out a rectangle. But can we prove why its opposite sides have to be equal? Or why its diagonals are always the same length? You see, just knowing what something looks like isn't the same as truly understanding it. So let's solve this little everyday mystery. And to really get our heads around a rectangle, we've got to start with its family. We're talking about the quadrilaterals. Now, the definition is actually super simple. Quad just means four, and lateral means side. So a quadrilateral is any shape with four sides and four angles. The only other rule is that it has to be a closed shape. All the lines have to connect and trap a space inside. Okay, so here's the first big rule for the whole quadrilateral family. It doesn't matter what it looks like. It could be a square, a kite, a trapezoid, even some really bizarre, wonky shape you draw. If it has four sides, the four angles inside will always add up to exactly 360 degrees, every single time. So why is 360 the magic number? Well, the secret is incredibly clever and simple. You can take any quadrilateral, draw a line from one corner to the opposite corner, and bam! You've split it into two triangles. And since we know every single triangle in the universe has 180 degrees inside, well, two of them together has to be 360. And just like that, we've found our secret weapon for this whole investigation, the triangle. So, if triangles are the key that unlocks everything, we need a way to use that key. And the tool that lets us do that is a concept called congruency. This is how we're going to prove everything. Congruent is really just a fancy math word for identical twins. If you have two triangles and you could just pick one up and place it perfectly on top of the other one so they line up exactly, every side, every angle, then they are congruent. They are exact copies. Now, the best part is we don't have to measure all 6 parts of two triangles to prove they're identical. We've got these awesome shortcuts, these little cheat codes. If you can show that all 3 sides match up, that's side, 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 or SSS, they're congruent. Or if you can show 2 sides and the angles stuck between them match, that's side angle side, or SAS. They're congruent. And finally, 2 angles and the side sandwiched between them, angle side angle, ASA, that works too. Okay, but this leads to a classic trap, one that gets a lot of people. What about angle, angle, angle? Let's say you've got 2 triangles and all 3 of their angles match perfectly. Does that mean they have to be the exact same size? Does that guarantee they're congruent? And the answer is no. It doesn't. Matching all 3 angles only proves that the triangles are similar, which just means they have the exact same shape. Think about it. You could have a tiny little equilateral triangle and a giant one. Same angles, right? 60, 60, 60. But they are obviously not the same size. So remember, AAA proves similarity, not congruency. All right, we've got our tools, we've got our rules. Let's start our investigation. And first up on the slab is the everyday common rectangle. So here's our first mystery to solve. We all just sort of know that if you draw 2 diagonal lines, corner to corner, inside a rectangle, those 2 lines will be the exact same length. But why? Let's not just accept it, let's prove it. Okay, to crack this, let's focus on the 2 big overlapping triangles that are created by the diagonals. First, we know a property of rectangles is that opposite sides are equal. So boom, that gives us one matching side. Next, we know both corners of a rectangle are perfect 90-degree angles. So we've got a matching angle. And finally, if you look closely, both of these triangles actually share the exact same bottom edge. That's a common side, so we've got another matching side. And there it is, side angle side. And because we just proved with side angle side that those 2 big triangles are congruent, that they're identical twins, then every single one of their corresponding parts must be identical too. That means their longest sides, which happen to be the diagonals of the rectangle, they have to be equal. Case closed. Okay, but wait, there's more. On to the next puzzle. Not only are the diagonals the same length, but they also slice each other perfectly in half. That point where they cross, it's the exact middle of both lines. How can we possibly be sure that's always true? So for this one, we shift our focus to those 2 smaller triangles at the top and bottom, the ones pointing at each other. Since a rectangle's top and bottom are parallel, we get those cool Z angles, the alternate interior angles, which are always equal. So we have an angle. Then, right where the diagonals cross, those angles are called vertically opposite, and they are also always equal. That gives us our second angle, And finally, we know the top and bottom sides of the rectangle are equal in length, so we have a side. With angle, angle, side, we've just proven those two little triangles are congruent. And if they're identical, their corresponding sides must be equal, proving that diagonals cut each other perfectly in half. All right, it's time for our last case file. Let's take a look at the rectangle's very special, very neat and tidy cousin, the square. Now, here's the really important idea to grasp. A square isn't some totally different creature. A square is just a special kind of rectangle. It follows all the rectangle rules. It has 4 90-degree angles. Its opposite sides are equal. It just adds one extra, very strict rule to the list. All 4 of its sides must be equal. And this is so cool because it shows how these properties build on each other. Because a square is a rectangle, it automatically inherits all the rectangle's diagonal properties. They're equal in length, and they cut each other in half. But that one extra rule, that all sides are equal, gives its diagonals 2 extra special powers. They cross at a perfect 90-degree angle, and they split each corner of this square into 2 perfect 45-degree angles. So, after all that, after all these proofs and angles and sides, what's the big idea here? What's the point of it all? Well, the biggest takeaway is that geometry isn't just some big list of random facts you have to memorize for a test. It's a system of pure logic. We just saw that all these properties are truths we can actually discover and prove for ourselves. And we did it all using one simple, powerful tool, the congruent triangle. It shows how a more complex shape, like a square, is logically built right on top of the foundation of a simpler one, like a rectangle. We just followed a logical thread, all the way from a basic triangle to the special properties of a perfect square. It kind of makes you wonder, right? What other beautiful logic, what other hidden secrets are just sitting there, waiting to be discovered in the simple shapes we see all around us, every single day?